Okay, so what we're going to be doing is we're going to be working through lesson 3 in the workbook on page 389, and it is going to continue with permutations. This will be the last lesson on permutations, and then lesson 4 is going to start combinations, and combinations will be 2 lessons long. This is where they're going to take permutations now, and we're going to be doing 2 different things in this lesson. We're going to introduce restrictions and something called repetitions. So restrictions is going to be the first part of this lesson or this first video, and then repetitions is going to be the second. What they're going to do in this lesson is complicate things quite a bit, and I'm going to give you exact strategies on if you see a question in this manner, this is how you would solve it. So what I'll often say when we go through these class examples is a lot of the examples that you see from this lesson you put on study sheets. So I'm going to say, if they word it in this way, this is how you solve it. If they word it in this way, this is how you would solve it. Okay? So let's deal with permutations with restrictions. So if you have a highlighter, highlight this word restrictions. Okay, it says, class example number 1. In how many ways can all of the letters of the word oranges be arranged if? So the first thing that we always do is count the number of letters in whatever your given word is, right? So take oranges and you'd say 1, 2, 7 letters, okay? So that's you can't mess up that, right? Like, it sucks when something, that we learned in grade 1 interferes with stuff we're supposed to have learned in grade 10. We all make those mistakes. Sometimes we'll count up those letters wrong, but you get the entire question wrong if you did that. So just make sure that's like the first thing you do. Okay, so we're taking the letters in the word oranges and we're going to arrange them and figure out like how many other 7-letter words we could make if there's no restrictions. So if there's no restrictions, there was different ways that we learned how to do this. So from yesterday, we learned fundamental counting principle, or from the first lesson, I should say. So with the word oranges, you could have set up 7 different stages. So 1, 2, 3, 7. And then you could have said 7 times 6 times 5 times 4, 3, 2, 1. So if there's no restrictions in the word oranges, this is one way we could have written it. You could type that in on your calculator, or we could have done 7 factorial, and that would give you your answer. That would probably be more efficient, okay? So 7 factorial, or writing it as a permutation, it would be 7 permute 7, right? So 7 permute 7 is the other way because we had 7 total objects and I got 7 stages. This is how you would write it when you start at the total number of objects and you go down to 1. You'd write 7 permute 7. So the one I would type in my calculator, which I think would be the most efficient, would most likely be 7 factorial, and 7 factorial is 5,040. So there's 5,040 different ways that we could arrange the letters in oranges if we used all of the letters. Okay, this would be considered a restriction. So let's write for B, this is a restriction. Okay, the first letter must be an N. So you'd say the first letter must be an N. And Rian, what am I going to write above the N here? How many N's are there? Just 1. So if the first letter must be an N, there's 1 choice to go there. And then this would be 6, 5, 4, 3, 2, 1. Typing this in my calculator, I would just probably say 6 factorial. And if you typed in 6 factorial on your calculator, you'd get 720. Different arrangements or permutations. using the letters in oranges if the first letter is an N. Okay, C you have not seen before. So A and B would need to go on a study sheet because you should be good with A and B. C would go on a study sheet. The vowels must be together in the order O, A, and E. So once I get to these types of questions, I want you guys to start thinking of discs. And what I mean by discs is, like with this question here, imagine a round disc, and one disc has the letter O on it, one disc has the letter R on it, one disc has the letter A, and you put it in a bag, and you would have 7 total discs with all the different letters. So what they are saying for this is the vowels O, A, and E must be together. So what that means is you would draw out a single disc from a bag, and on that disc, you would see the letters O, A, and E on the disc. So one disc contains the letters O, A, and E. And then you'd have to say, okay, well, what would the other discs contain? So think of the word oranges. So I'm just going to write it here. So O-R-A-N-G-E-S. So O is gone, A is gone, and E is gone. So what that means is I would have another disc with the letter R, another disc with the letter N, another disc with the letter G, and another disc or last disc with the letter S. So the vowels O, A, and E must be together. So I've got O, A, and E together on one disc. And from here, how many discs do you have total? That's 5 different discs. So there's 2 ways you could do this. You could say, okay, how many stages would you technically have? There's 1, 2, 3, 4, 5 different stages. So if we were doing this by the fundamental counting principle, you would say there's now 5 stages because O, A, and E must be together. So if I was drawing this from a bag, there's 5 choices to go there, 4 to go here, 3, 2, and 1. That typed in your calculator would be 120, would be your answer. So there's 120 different arrangements with the letters O, A, and E together. What we're going to do though when we do these like questions, and I say think about these as discs, is you're going to look at the number of discs, and that's going to tell you how many factorial you have. So 1, 2, 3, 4, 5 factorial. So that would be 5 factorial, which is 120. Okay. Now, what is important to sort of highlight or to box in for the one we just did is, and the reason why this example would go on a study sheet, is what it says is it says the vowels O, A, and E are together in that order. So they want it O, A, E. The next example, class example 2, we're going to do the same type of example. So this class example 2 would go on a study sheet because they're going to change something slightly with this one. So what they've done in this class example is they gave us the word brains, okay? So they gave us the word brains, and they want the vowels together. So let's just figure out what are the vowels in the word brains? Like, what are they? What do you guys think? What are the vowels? A and I. So let's create a disc with A, I. Now, the wording is important, and the wording is what's going to get some of you. This one said the vowels have to be in this order, right? They got to be. So there's only one disc with O, A, and E. This one says how many different arrangements of the letters brains where the vowels are together. So I wrote AI. There could be one other disc. Do you guys know what it would be? IA, because it didn't specify. So here's what we have to do. let's figure out the arrangements with AI together. So with brains, let's do the discs. AI is together. So what would be my other discs? I would have a B, an R. AI is already used up, so I would have an N and an S. Okay. This would be 1, 2, 3, 4, 5 discs. That would be 5 factorial. 5 factorial is 120. Or what I could have, because they didn't tell me that the vowels have to be in a certain order, the vowels could be on a disc with AI, or they could be on a disc with IA. And then we would have B, R, and S. This arrangement would be 5 factorial, which is equal to 120. What do we do if it could be this or this? You add. So if it's that or that, that implies that we add. So our total number is going to be 240 different arrangements. Now, for these questions, I don't actually want you to do the or. Okay, so I'm going to show you a different method. Like, I don't want you to do this or this, because if you have only 2 letters, it's easy, right? If you have 3 letters, 3 vowels, you will actually have 6 different ors. So how you're going to set it up, and I'll show you again when we get to A. So I'm going to show you we're going to do this exact same thing, and they're going to do 3 things must be together. Here's how you're going to do it. So this is one method, which you could have, but it's not the method you're going to do. What you're going to do is you're going to have your disc set up just one time, and you are going to say that the disc setup is 5 factorial. Then what you're going to do is you're going to say this was the disc that could be arranged in different methods, like it could be AI or IA. So what you do is if it doesn't tell us and it doesn't specify, you say how many letters are on that disc, and in this example there's 2 letters. So you're going to multiply it by 2 factorial. If we had 3 letters here, you multiply it by 3 factorial, because 3 factorial, you guys, is 6. 3 times 2 times 1 is 6. If you had 4 letters on this disc, you'd multiply it by 4 factorial. Okay? And then if you typed it on your calculator, actually we don't even have to type in 2 factorial, because what is 2 factorial? You could do this in your head. What's 2 factorial? 2. 2 times 1. So on my calculator, I'm just going to type in 2 times 5 factorial, and watch what I would get. Number 4, 240. So I'm going to show you now with the word kitchen. Okay, so we're going to look at class example number 3. Okay, so again, this would go on a study sheet, because these are all the different scenarios that you would see. So what it says for number 3 is it says, find the number of permutations of the letters in the word kitchen if K, C, and N must be together, so they go on a disc. K, C, and N. But it says not necessarily in that order. So what that means is, like, it could be K, C, N, it could be K, N, C. It could be C and K. Like, there's going to be 6 different permutations of K, C, N, because that would be, there's 3 letters, that's 3 factorial. So just for now, whatever they want on a disc, put it on a disc. Then set up your other discs. So let's do our other discs. So K, C, N. So I'm going to take out the K, the C, and the N. Okay, I'm going to have I on another disc. I'm going to have T on another disc. I'm going to have H on a disc. I'm going to have E. Does everybody agree that this is how you would set up the discs? Okay, so we're in agreement. how many discs total? Can you draw from? How many discs? There's 5. 1, 2, 3, 4, 5. Just like up here. 1, 2, 3, 4, 5. You do the total number of discs, which is 5 factorial. You would stop here. That would be my answer. If they said in the order KCN, like there's no other arrangement for this. But they said this, it says not necessarily in that order. That means this could be in any order. So what would I multiply this by? How many letters are there on this disc? There's 3. So it's 5 factorial times, I gotta take care of that disc because they said not necessarily in that order. So that means just do by 3 factorial. And if you type it on your calculator, 3 factorial times 5 factorial, you're gonna get 720. Different arrangements of the word kitchen if the letters K, C, and N are together. Okay, so on study sheets, you are going to put, so you're gonna put brains, right? And you're gonna show that there's 2 different letters that could be arranged, so 2 factorial, 5 factorial. Then you're gonna put kitchen, and that was showing you 3 different letters, not in any order. And then you're gonna put, what word was this? Oranges. This one here, they said O, A, and E must be together, like in that order. This one here, we did not do, we just did 5 factorial. We did not do 5 factorial times 3 factorial, okay? So have the word oranges, brains, and kitchen on there, and then have in this order, it doesn't tell us what order, and not necessarily in this order, which means it could be in any order. Okay, let's do B, and you're going to star B. And you're going to highlight the word not. Okay, so the words, how many arrangements from the letters in kitchen can we make if the vowels cannot be together? So first of all, let's figure out what were the vowels. Okay, what were the vowels in the word kitchen? So what were they? You guys, what are the vowels in the word kitchen? I, and what's the other one? E. Okay, so there's 2, I and E. So what they are saying is, how many words can we make if vowels are not together? That is really, really difficult to figure out. How many different arrangements are there not together? So what we do in math is we do the opposite of that, okay? So if ever you see that words or letters cannot be together, like they've got to be separated, what's the opposite of not together? What's the opposite of vowels not being together? Putting the vowels together, right? So the opposite, whenever you see the word these can't be together, how you're going to do the question is how many different arrangements are there with these vowels together? Now, this is something called the complement. So in math, and I want you to write this down, in math, when you do the opposite of something, it is called the complement. So you in permutations and combinations are going to be doing the complement whenever I tell you these things cannot be together. So pretty soon we're going to do like, how many different arrangements can 5 students take a picture if Haley and Gabby cannot be side by side? The complement of they can't be together is you put them together. That's the complement, it's the opposite. So if two kids can't stand next to each other, then the complement of that is you put them next to each other. Now, when we're doing math with the complement, how we do this is as follows. You find out the number with no restrictions. And you subtract the complement. And in this case, the complement was vowels together. So if I say the vowels cannot be together, you're going to put them together. We always put them on a disc. Okay, that's how we always do it. Put them on a disc. So if they can't be together, you're going to do the opposite, which is put them together. But in order to get the math correct, you always have to first do how many arrangements are there in the word kitchen if there's no restrictions, and then we're going to subtract the complement. So if we have no restrictions in the word kitchen, that would be 1, 2, 3, 4, 5, 6, 7 letters. That would be 7 factorial. Minus. Now we have to figure out the complement, which is vowels together. So vowels together means IE goes on one disc. So now we have to figure out how many discs do we have if the vowels go together. So IE goes on one disc. And then we've got K on another disc. T's on a disc. C's on a disc. I, T, C. H is on a disc. K, I, T, C, H, E, and then N would be on a disc. If I said how many different arrangements are there in the word kitchen if the vowels go together, would you guys be able to figure this out? How many different discs do you have? And then what would I do for IE? It could be IE or it could be EI, right? So you would say, okay, this, there's 1, 2, 3, 4, 5, 6 different discs. And this one here could be IE or EI, so there's 2 different letters there, so this would be your math. Vowels together would be 2 factorial minus, or times 6 factorial, and whatever that answer is, you'd subtract it from 7 factorial. So type that in your calculator and see what you get. And we'll do more of this complement in the next lesson as well. There will be no more complement in lesson 3, but when we do lesson 4 or 5, I'll give you examples of the complement. Okay, anybody have this answer? 3,600, yeah. So there's 3,600 different arrangements for the word kitchen, and you'll never see an I and an E together. Okay. Let's look at class example number 4. In how many ways can 3 girls and 4 boys be arranged in a row? If ever you see a row, like we're putting them in a row, lining people up for a picture, arranging kids in a row, fundamental counting principle is the way you want to go. Okay, so if ever you see that word row, we're going to set up stages. How many different stages will I have, or how many kids do I have if I'm arranging 3 girls and 4 boys? 7 stages. Okay, So let's set up our 7 stages. 1, 2, 3, 4, 5, 6, 7. Okay, so from here, here's what I want you to look at. What the restriction is, how we're going to arrange these kids, is no 2 people of the same gender can sit together. So don't worry about the complement or anything like that. Just no 2 people of the same gender can sit together. How does it mean they're going to be arranged? Like, what is it going to look like, basically? Boy, girl, boy, girl, boy, girl, or girl, boy, right? So you don't really know what goes first. Do we have to put a girl or do we have to put a boy? For these questions, some of you could be like, ooh, I know which gender needs to go first. Some of you will have to do this. Girl 1, you're going to test it out. So just watch up here for a second and tell me if I did this right. Girl 1, boy 1, girl 2, boy 2, girl 3, boy 3, girl 4. Did I do it right or wrong? I did it wrong, right? The reason why I did this wrong is because, Haley, how many girls can there be? 3. And if I set it up with a girl first, I got 4 girls. So I'd be like, nope, I gotta erase this. So now we know, let's set it up. We've got, it has to start with a boy, right? So sometimes you might need to guess and check. So boy 1, girl 1, boy 2, girl 2, boy 3, girl 3, boy 4. And I'm just gonna double check. It said 4 boys, I got 4 boys. It said 3 girls, I got 3 girls. Okay, so let's set it up with the fundamental counting principle. How are we gonna put the numbers in here? Boy 1. How many choices of boys can go in that first spot? There's 4 of them. 4 boys can go there. Once one of the boys is in its place, there's 3 boys to go there. There's 2 boys to go there. And there's 1 boy to go there. And then you're going to do the same with girls. Kathleen, how many girls could I put here? 3. So you're going to say 3, 2, 1. If you want, there's 2 different ways you could type this into your calculator. You could do 4 times 3 times 3 times 2 times 2 times 1. Or, if you wanted to, you could have said 4 factorial times what factorial? 3 factorial. And either way, you would get the answer of 144. Now, 144 different arrangements. So different arrangements or permutations if boys and girls are not sitting together. So you guys, I want to show you sort of or explain the power of setting it up like with these stages. If, let's say you had this question in your homework, right? And you were to look at the solutions, this is the only thing the solution would give you. It would give you 4 factorial times 3 factorial and then 144. And sometimes like that's not enough to be like, well, what, like how are they getting 4 factorial and 3 factorial? And then seeing it out like this, right? All the kids in a row, it helps, okay, oh, that's where they got the answer of 4 factorial and 3 factorial, right? So it's helpful if you're able to like visualize this, and that's how they got the answer. Okay, let's do this one. Now this one, we are not going to do the stages. We're gonna do, think of this in permutations. 6 actors and 8 actresses are available for a play. So there's 6 actors and 8 actresses that the producer or whoever does the hiring gets to choose from. Okay, so 6 actors and 8 actresses are available for a play. There's only 4 male roles and 3 female roles. So this would be like, if you wanted to do this as a fundamental counting principle, okay, I could show you. There's 4 male roles. 1, 2, 3, 4. Okay, so there's 4 male roles. What am I going to put here, though? This is for the men. How many men are there to first choose from for the first role, for the lead role here? 6. So there was 6 actors to choose from to go there, right? There's 6 actors. And there's 5 after the first role is cast, and there's 5, 4, and 3. And that takes care of the males. And then there's going to be 3 female roles. So 3 female roles. And there was 8 actresses to choose from. 8, 7, 6. Or here's how your book did it. Your book wrote this. See if it makes sense to you. 6 permute 4. So they did this, and they just, instead of writing this, they did not write this in their key. They just said, there's 6 actors and there's 4 roles. So there's 4 stages. So the book just said 6 permute 4. That word and means multiply. And then they did the females. 8 permute 3. That's the way your book did it. It says the book said this is how I would have done it, right? You could do it this way if you see it, or you could do the fundamental counting principle, whichever you think is more intuitive to you. Either way, Angel, what are you getting for the answer? Yeah, 120,960. Okay, 120,960. So what I want you to do right now is circle questions 1 to 5. I'm going to see if there's an or. Question. Okay, so I'm going to open up. We'll quickly talk about which one is the complement, and I'll set up a complement with you. Okay, so I want everybody to look at, before you get started, at 4B. Okay, so let's do 4A together right now, and then we'll set up 4B. So Anne, Brian, Colin, Diane, and Eric go to watch a movie. So we're gonna put these on discs, right? I like thinking of the discs for these. So Anne, Brian, Colin, oh, look how they set this up, how nicely for us. A, B, C, D, and E. They go to watch a movie and they sit in 5 adjacent seats. So you could like do your little rows. But when we're putting things together, I like thinking of it in the disc. Brian, how many different ways can this be done? If these guys go to the movie and Brian sits next to Diane, that means they go on a disc together, right? If Brian and Diane are together, they go on one disc. So on one disc, I'm going to put Brian and Diane. What that means is I've got another disc with Anne on it. I've got another disc with Colin, A, B, C, D, and then Eric needs a disc. So try to think, like, if you're able to, think of discs. Okay, so if you were to do this one, how many different discs total do we have? 1, 2, 3, 4 different discs. And then do you want me to multiply that by something? 2 factorial. Yep, because Brian and Diane are next to each other, but it could be Brian, Diane, or it could be Diane, Brian. Doesn't say, right? So I'm gonna multiply that by 2 factorial. So this answer would be 2 factorial times 4 factorial, and that's 48. Okay, here is where we're gonna use the complement. Anne refuses to sit next to Eric. So if 2 people can't be together, like they gotta be separate, that's where you're always gonna use the complement. What's the complement of Anne and Eric refusing to sit next to each other? Putting them together. Yeah. So this one here would be the number with no restrictions. So the number with no restrictions would be 1, 2, 3, 4, 5 different people can sit in any order they want, 5 factorial. Minus the complement of these guys not sitting next to each other because they fight is you put them next to each other. So the number of arrangements where Anne and Eric are together. Anne and Eric together. So Anne and Eric would go on one disc. And then we would have, who would be on different discs? Anne and Eric are together, Brian, Colin, and Diane. So the complement is Anne and Eric together. And that would be, there's 4 discs, and Anne and Eric together, it could be Anne, Eric, or Eric, Anne. So 4 factorial times 2 factorial. So this minus total number of discs is 4 factorial, but then that disc is 2 factorial. And then you get this one. For number 5, arranging adults and children in a line, you could do, oh no, there's 4 adults and 5 kids. You could do your 9 different stages, right? Because you might need to figure out, but like this one, you shouldn't need, without restrictions. It's just, there's 4 adults plus 5 kids, 9 people total. 9 factorial is how you would do 4 adults and 5 kids with no restrictions. 9 factorial.